Okay guys, the last thing we need to do in this unit are currents, and just keep in mind that a current is a large mass of continuously moving water. We're going to focus on global currents as we do our assignment today. So these are the largest currents that move across oceans. So one that I know you've definitely heard of is the Gulf Stream, which flows, where are we? Over here. Okay, the Gulf Stream flows here on our east coast. And you guys know that these are weather makers, okay? Depending on how the currents are doing, depends on hurricanes, it depends on the weather off the coast, it depends on flight patterns, all kinds of different things, okay? All right, so one of the reasons we have this is the Coriolis Effect. So this is how the Earth spins, and it causes the wind and the surface waters to move in different directions. So in the northern hemisphere, they move clockwise. In the southern hemisphere, they move counterclockwise, okay? And that's not true of toilets, as they proved on Mythbusters or something some time ago. Okay, so of course it's not just oceans, there are continents, and these deflect the currents, and it causes them to move in really big circles that are called gyres or gyres, and people call them surface currents. Okay, and it's really important since they help plankton drift around and circulate. Because remember, plankton can't swim on their own, they can only float, and neither can jellyfish. Okay, so there are also vertical ocean currents, which means the water can move up and down instead of horizontally, but this is not because of the wind or the land patterns or anything like that. This is because of temperature differences. So you guys have always learned that warm air rises and cold air sinks, probably in earth science. That's how a lot of our weather patterns happen. If you have a two-story house, you may notice that in the wintertime, upstairs is warmer than downstairs, and in the summertime, downstairs is cooler than upstairs. Okay, that's because the same thing applies in the ocean. Warm water sinks, cold water sinks, warm water rises, and that's because of its density. Okay, so this creates something called a convection current, and one of the good things about this is that keeps oxygen circulating as well. Okay, so if you think about the Earth as a whole structure, you're going to have warmer water at the equator and cooler water at the poles, so that's going to create a current. So that's going to create it sinking down towards the equator and rising up towards the poles. Okay, so there are some deep ocean currents. Countercurrents are currents that move in the opposite direction to wind-driven currents. You guys have probably felt that, like an undertow. Turbidity currents are currents that are found along the continental slope, and that's because of its really deep, fast decline. And then upwelling is also very important. This is how nutrient-rich sediments from the bottom can actually float to the top. So upwelling is extremely important to get nutrients circulating in the oceans. Okay, all right, so a couple more. The undertow is what I was talking about a few minutes ago. If you guys have stood at the beach where the waves crash, right, where all those broken shells and things are, you can actually feel the rush of the water pulling backwards toward the ocean, right? And it's called an undertow, and it makes you feel like you can lose your footing. Okay, it's very strong. You guys have probably seen sandbars. That's what in this picture down here. It's where sand that has been eroded away gets deposited a short distance from the shore, and that's because of the undertow and the recurring waves and things like that. And something that's super dangerous, especially off our coast, are rip currents. These are narrow currents of water that rush seaward, and generally the best way to get out of a rip current, if you remember, is to swim parallel with the shore until you don't feel the current pulling on you anymore. Okay, most people don't drown from rip currents because they can't swim. It's because they get too tired and then they run out of energy and then they drown because of that. So you can't fight the rip current. You're supposed to swim with it, which is parallel to the shore, until you don't feel it pulling on you anymore. All right, and then the last one up here is a whirlpool. So this is rapid movement of surface waters in a circle. And that's where actually we get whirlpool action in hot tubs and things from. So it can move in circles and it can pull things down and actually drown them. Okay, So that's our unit on currents. If you could complete the worksheet that I gave you. And that'll be it. We'll move on to living things starting tomorrow. Thank you. Have a great day.